Hello everyone, I just been watching the examples of the POPs, the new family of TouchDesigner. I didn't have time the last month, so actually right now it's just the moment that I know I have time, I don't have anything to do, so I've been just learning a bit and exploring. I discovered something really cool. I'm so excited. It feels like the Christmas for me. I know it's a bit weird to say, but because it's summer. But the thing is that I discovered that because TouchDesigner was a branch of Houdini, there is still ways that you can export Houdini objects and read the attributes within the new system in TouchDesigner. And because I've been learning a lot of Houdini, I am in love with the software. And at the same time, I'm amazed with TouchDesigner, and I've been using it for the last 10 years. So it's something I kind of have my second nature in this software. So yeah, you can imagine I'm really excited. I generated this really funky thing in like 10 minutes. It's so easy to make right now. And I'm so excited to explore the new possibilities that exist within TouchDesigner and Houdini. And what I'm going to do is I'm going to show you how I did this. As you can see, it's reactive to my voice at the moment, but it could be audio reactive. I was so inspired by the work of Vincent House, which I think he's been working on this system. So I just want to thank him because when I saw that video that he did for Max Cooper, I don't remember the name of the actual song, but it's just so beautiful. I really will leave a beautiful link so you can look at it. And it inspired me for my career. So actually now I can jump into it and show you as well how you would approach to do this kind of underwater noodles, if you want to call them. Okay, let's jump into it. I'll just show you. And if I have a moment, I will see if I can recreate that in TouchDesigner without the need of using Houdini. But let's just see how this works. This is the TouchDesigner network. It's super simple. Like if you look at this and you've tried to do this before, you will know that it is actually kind of crazy that it can be so small. But that's probably, I will leave this in the back here in the corner. But the thing is that the TouchDesigner, the experimental version, that's where I am in the moment. I just downloaded the thing. I'll leave a link as well if you're interested to try it out. So it's available as an open beta. What's very interesting is that they have this new family of operators, which are gonna allow us to generate geometry and also modify geometry through the use of attributes. And for those that maybe have never done that before, basically we will understand geometry as a set of points, which can then represent a set of primitives and vertices, and all those components of a geometry, which we can also call a mesh, will be used to define certain attributes. And those attributes then we can use to adjust the behaviors or the ways that we want to change geometry. In this simple case that I made, I have this geometry that it's right here. And as I mentioned, the attributes in this specific case I made in Houdini. But they have, for example, a color, as you can see here. They have like this gradient that goes from black to white on the top. And they have a position. They also have a class, which represents an ID for each tube. And they have a mask attribute and also a p-noise attribute. What you can do then now in TouchDesigner, that's something that you couldn't do before, is to add noises in the SOPs, right? So that was like the way we actually used to add noises to geometry. But that was not good in a way, because this was using the CPU in order to calculate the displacement of the vertices. That was not a problem, and now if I would add a sphere, still a lot of people actually use this method, and it actually works, but the thing is that at the moment you scale the system, it would completely crash, right? It's not that ideal. So what you would need to do then is to actually use instancing, which is a different way to approach a project like this, and then per instance modify their geometry. The thing is that, as you can see, these displacements are quite complex actually. So what happened is that we had to make custom GLSL geometry shaders, which it's not that accessible for most people, and it made it that this type of work was not that accessible using TouchDesigner in the past, right? With this new update, what that will allow us is to not have to code directly in GLSL, but what it does is to allows us to actually modify and generate attributes in order to modify geometry. So in a way, kind of forget about SOPs for a while, at least I will, and I'm gonna just try to learn a lot of the new operators. Turns out that I've been learning Houdini for the last years. It's been like my go-to software for doing very crazy stuff as well. I've been just doing characters and very strange things. And the thing is that the knowledge that you will learn from there, it really translates extremely well to this new workflow in TouchDesigner. And I have to say that the other way around. The knowledge that you would have in TouchDesigner is going to translate really well in order to go to Houdini. If you have been working and you are interested on this, if you are going to be using Blender for your geometry, I think that's a very good software, but I would recommend you to give a try to Houdini because it will actually make a lot of sense at this moment to learn it, because it will allow you to extend your knowledge into such a way that it's just like kind of insane. That's my opinion. You can still use Blender, but let me show you. I generate this geometry in Houdini, I modify an attribute, and I can add the noise to those noodles, right? As I mentioned before, this previously we would have required an instance setup with geometry, and now it's just one operator, which is kind of insane. I haven't had a lot of time to fiddle around this setup or this system, so I'm not sure to what extent it will replace instances or not. I want to do a few tests when I have a bit more time. I'm now just very excited to just try out. Anyway, the output is rendered in a geometry, which I'm using a PPR material, and I'm using an environment light that fetches a noise as a texture. So that's the way I get the color, right? I could give it a different seed. Let me copy this one. I kind of like this one. And I can change now my color. Pretty great. There's a light with shadows. It's like very simple setup. I'm just going to stop cooking this for a second. They look really cool, but it takes a little bit of computer power, and my computer is kind of not that great at the moment. But I'll jump to Houdini and I'll show you that the network is not insane. It is a relatively small network, and just for those that are in the TouchDesigner world, I'm just gonna say there's a few key differences, and the main one is that Houdini has contextualized network operators, and I know that sounds crazy, but what I mean is that the amount of operators that we can use depends on what type of network we are in. TouchDesigner, in the other hand, is a single network instance. It means that wherever location you are in the network, you will always get access to the families of operators. In Houdini, that's not the case. What we want to work on is something called geometry, and that's also, funny enough, called like SOPs, the same way that the designer are called SOPs. So if we want to generate any geometry, we have to be in this network. If we are somewhere else, like if I'm going to make like a ROP, for example, in Houdini is to export things, then you are in a different context. And for example, here, I cannot add a sphere, right? Just to heads up for the designer folks over there. In my geometry, it's relatively straightforward. I have a circle, I'm scattering some points, I'm adding attribute noise to change the scale of them, and I'm copying these tubes, which are generated by a single line that gets swept, and it's matched into the size. So actually, what this is going to do is to match them at the floor, and I copy one of these tubes for each of the points of my scatter node, and the point scale basically will change the size of that. You can see already like the similarities between this and the TouchDesigner setup are super similar, right? So that's very, very interesting. Anyway, I am making a gradient, and that gradient I will use to generate a mask. And that mask basically will be set as an attribute. In Houdini, the way we work with attributes, it's mostly through a few methods. Most of the times you can create them like with operators like this. That would be quite similar as in TouchDesigner right now. Let's say that we want to create an attribute, right? And here with this, we will be able to create an attribute in the same way, setting what class it's going to be, setting other type of things. Back in Houdini, what it's very powerful, at least of this software, is that they have a special language called Vex, where you can type those things. And here, the Houdini, it's actually crazy, right? I think you can compare this to GLSL in TouchDesigner. I think that's what we are going to do when we need to deal with like complex operations and actually going a bit more deep. So I think that this will be the equivalent of the GLSL, where we're going to act directly towards the geometry. Then I'm adding another noise so that my tubes are a little bit more different. Otherwise, they are a bit boring. And here I could change the seed, or I can make whatever I want. We are in the Houdini world, so now it's kind of crazy. And I'm making an attribute called connectivity. And this, what it does, a bit like the TouchDesigner instance, it's going to give an ID to each tube, right? So for each connected piece, you will see here that it has a class, and it's now visualized by a different color. Each color is a different ID. And what I'm doing with that is I'm creating a second noise attribute, and that's going to be used in order to fetch the position that will move the noise of our tubes. And I'm going to show you, I know probably it sounds like really chaos, but I'm so excited that it's probably going to sound like a lot of information at once. But bear with me, I will slowly talk about this over the coming period, so it will be fine. Anyway, we are set up with our geometry. It can be whatever you want. I just made this simple setup. I guess it's relatively easy to follow. It's not about showing you how to do it exactly, but just to get the grasp of the abstract idea of what it is. Here, like the kind of interesting discovery that I did is this format. It's the H Classic. I guess that not a lot of people know this format, but you can actually export geometry in Houdini with the H Classic. And as far as I'm concerned, you don't need any paid license in Houdini to export this format. So what that means is that actually we could do this network with the free license of Houdini, a non-commercial one, and of course just experiment with TouchDesigner, which is also free, right? Of course, you have to check, right? If you're going to do paid projects, eventually you have to get a Houdini license, right? But it's very nice because that means that the accessibility of this style of work will be super open now, because we don't need to have a paywall for Houdini in order to be able to export this geometry with attributes. And that, if I'm going to look for it, it's actually, I'm back now in TouchDesigner, so I'm going to recook it. And right here, it's importing a file, right? And you can see that I'm importing the H Classic format. As I mentioned, TouchDesigner was a branch of Houdini, so there are a lot of things that are very similar, and they were before already. But the fact that they still have this format and you can still import parameters, I found really, really exciting. And that's what we're going to import. I'm going to import that saved file that I made from Houdini. And what you can see here is that I also fetch all the attributes that Houdini offers to me, right? I can, for example, thin a bit the amount of preview attributes. And you can see that it brings like the index, the index is actually just a column of the designer, but it brings us like the position, the color, the normals, the class, the mask, and the p-noise. Now let me talk about why I made a p-noise attribute. And I'll show you very easily by just copy-pasting this noise. And I'll change the noise lookup attribute to the position, right? And that is actually the default attribute for your noise. You will see that when you make a new one, it will say the upper P. And now you can see a bit the difference between the two is that if you use the position for the lookup of the noise, they become a stack of movement, right? It's a little bit complex to understand, but basically think that we are going to use a randomized seed per tube so that the noise lookup is not in the same position. When it is in the same position, which is by using this upper P attribute, it will get this cohesive movement, which might be desired, right? But I think at least I like a lot more when each individual tube is doing its own thing and is not actually being affected by that. The way I made that attribute is really simple. It could technically be a little bit randomized, but what is important is to keep the position of each point for each tube. How that attribute is made in Houdini, at least, is using a point wrangle, and I add the class, which is an integer that goes from 0 to 149, and it is added to the p noise. That is technically possible to do here as well, and I will show you when I remake this in TouchDesigner. So stay tuned for that. That is what this p noise is going to do, and this math is basically adjusting the strength of that p noise, right? So if I disable this math operator, you will see that now my noodles are a lot stronger, and sometimes I kind of change a bit, which can be nice, but I liked it a little bit more subtle. But you could also like multiply it by 100 or whatever you need. That's up to you. So I'm going to delete that. And that's about it. The last thing that I actually did is that I am using this new page of the map, which is awesome. This is something that we couldn't do as well in TouchDesigner before, is to map attributes to parameters. This is just like my head is blown away, okay? That's all I can say. Anyway, what it's doing, which is also now represented with this representation here, we can see that my amplitude of the noise is going to be multiplied by an attribute. And that attribute is represented by this color, right? This is really common in game design. And imagine that I have this mesh, and I give the mesh a gradient from the root, right? So from the bottom of the mesh to the top. And that gradient acts as a mask, right? Imagine like a mask in Photoshop. Instead, it's a mask that is stored in the attributes of the points. So the points at the very top will be a value of 1, and that means that the amplitude is multiplied by that 1. Means that the top of these tubes will move a lot more than the bottom, and that's what gives this kind of garden aesthetic to these noodles, which is very, very nice. Let me save this, by the way. We could adjust this attribute. For example, I can add another math to this, and I can actually just adjust it, because why not? And for example, this math, if I now multiply, you can see it's affecting the position, but I can say I want to affect my mask. And if I multiply the mask, you can see that now the mask will go from, instead of 0 to 1, from 0 to 6. And that means that the top of the tubes will be multiplied by 6 instead of 1, right? And that basically generates that intensity change within the mask. What I could also do probably is to add a little bit. So you're going to see that now all of them are going kind of crazy. But you could also subtract as well. So that means that they're going to go over there. I'm sure that I could remap it. I'm now also just experimenting. As I said, I just opened this experimental build today, so bear with me. But I guess that we can map it. So for example, if I map this a little bit like that, so map to low, let's see. Well, it doesn't really matter too much, but there you go. So here I can adjust a bit the mask with these parameters, which is very, very nice. Then the amplitude at the moment is being driven by an expression. I'll just explain it for the people that use Houdini and might be interested on this. And is that I'm just getting the audio device in, which is my microphone at the moment. I'm analyzing that input audio, and that is being analyzed by the RMS power. And I'm lagging it. This is basically to filter the audio. That is where the designer gets absolutely cracked. I can show you the difference between the two inputs. The first one is a lot more noisy, and you can see how it sort of smooths out the value that I'm actually gonna reference to the amplitude of the noise. And I'm using a lag because I don't know if a lot of people know this, but a lag allows you to choose different values of filtering depending on the initial lag or the follow-up, right? That means that every time I talk a little bit, the peak goes a lot faster, higher than when I stop. And that's, it's a bit nicer than just to filter all of it together. That's it. After that, I'm just controlling a bit this. And I guess if you get this file, you can input your microphone and you will need to adjust the value with that, right? So what you can do here in the math, you can multiply how strong you want that audio to react to the thing, and then you can see that now it goes a little bit crazy, but that's also fine. You know, you can just play with it. And that's it. It's just so simple. I'm so amazed still. I said it so many times. I apologize in advance, but this is extremely simple to create something like this, whereas before I would have taken a little bit more time than, 15 minutes that this took. Well, the last thing I want to do now is to try to recreate this imported geometry within the things that now the designer offers us. I think to do something like this, it's definitely possible. So I'll just try to make it in a similar way. I don't know how long it's going to take, so I might cut a bit and see how it actually works together. In a way, I have not done this before, so I also think it's valuable to just see my thought process on how I would approach this coming from a Houdini background. So I think that's an interesting approach. I know quite a lot of touch designers. I feel comfortable to just dive without knowing exactly how it will work. But I will get there. I'll get there. Well, what I will need, and I'm going to mirror a bit, I'll just go back and forth to see what I did in Houdini and see what I should do in TouchDesigner, right? So first off, I need to scatter some points and I got to copy some tubes. Okay, so let's check that. I'm going to go from the things I know already. I know that in SOPs there were a tube. So I'm going to assume that it's going to be a tube in the POPs. That's also true. That's great. So I can delete the SOP one. And usually when I had to scatter in TouchDesigner, there was an operator, but I forgot the name because I don't think they called it scatter, right? It was a funny name. That's what I remember. Let me see if I check here. Yes, sprinkle. I think it's the sprinkle. Okay. I don't know why they call it sprinkle, but I think it's this one. Let me see. So what you could do is to sprinkle some points into the box. I don't know about that name, by the way, but that's what I'm going to do. Then we start with the circle. That's what I'm going to start with. The connectivity should be like a surface, the same I have in Houdini. And I'm going to flatten it out in the Z and X plane like that. And now I'm going to sprinkle some points over here. Why not? And there are a lot of points. So what I'm going to do is to reduce that. I think I set it to 150. I'll just try to recreate it to see how far I can get. So I'll do 150. And now I got the points. So what I need now is my tube, which is over here. And probably I gotta set a bit higher size, right? Because my size here is quite bigger. So what's the size of my circle is a size of 5. So that's what I'm gonna do as well. My uniform scale to 5. And then I need the tube. And the tube, I'm also gonna try to copy it a bit. So it's a radius 0.1 and it's just, wow, okay, let's see. Radius is gonna be 0.1, it's quite small, something like that. I'm gonna anchor it into the bottom. That's the same as the size match. And then I need to copy this into my sprinkle. So I'm gonna get my sprinkle. I guess there will be a copy. There is a copy, that's true. And it seems quite similar. There is the data and the template. So this probably goes on the top. That's my data and that's my template. There you go. Okay, that's kind of nice. I kind of know this as well because the SOPs also had this framework, right? So it's not that I'm a genius or anything, but I worked a lot with SOPs too. So I guess that they are quite mirrored. It's just that the framework in the end kind of changed quite a lot. That's nice. I will add some caps into my tube. Let's see. In my tube, there should be like a cap here, right? There you go. Okay, that's nice, but I don't see... It's a bit a shame. Yeah, that's not so fun. I cannot make like the round. I'm sure that you can. I just will not spend too much time on it for that. What I know is that when we want this type of displacement, I need quite a lot of divisions, and actually I have them, so that's kind of nice. So I might add a few more, so like let's say 30, 40, something like that. That should be like that. Cool. Now, I need a few things, but I could actually copy this noise and see if it actually goes already. And there is a few issues because I don't have this attribute, but I'm just going to set it as a P. And I'm also not going to mask I'm not going to mask this at the moment. And now I see that they actually move. Great, that's perfect. What I'm going to do is to make a bit of space, and I'm going to add a switch. Is there a switch here? Switch. Switch. There is a switch. Give me a switch. And I'm going to switch between the Houdini file and this new thing I'm doing. So now I can actually preview the thing. I'll put it here in the back on the bottom right. There you go. Great. Now we need to kind of get a few things. Okay, because I'm not sure how to do this, I'm going to write it down. First, we need to make a mask based on the height. And then I probably need to make ID attribute from sprinkle. That's what I would say, right? So what I mean is that each new point of the sprinkle would give a number to my copy. I guess that's what I need, because that way I can create the class attribute, which I generate like that. And in this way, I can then add that number of the ID of the class to the position, and I can generate this randomized position, which I will go another day in depth why this works, but it's not today. It's another day. Anyway, I need the ID of the attribute. I will need the mask, base height. What else do I need actually? That's it. So maybe I'll start with the mask, because actually my mask, I'm adding it here. So I'm adding it after the copy. So maybe there is like a ramp. No, it's not a ramp. So how can we actually do that? Let me think about this for a second. Okay. Well, technically, we know that my tube has a height, right? We know the height is 1, and I can make it longer or shorter. So that's really cool, actually. Look at that. Ooh. Okay. So I know that it has a height, and I could store that height as an attribute. At least I suppose you could. And here I can create an attribute from, let's say, the name is going to be custom. And I'm going to call it mask, because that's my height. It's going to be a float 1, that's true. And I'm going to, you can make also an array, and you can set it as a color. Okay, to see if I can create this attribute, I'm just going to do it like this. And indeed, I made a mask attribute. The only thing is that this only initializes the attribute, and that's not what I want to do. I want to actually set it, so I'm not sure about that. Let's see. Attribute combine. The attribute combine pop takes multiple pop inputs and lets you choose attributes for each input by name or by pattern matching. Maybe it's this one. Okay, I'm gonna check if I figure this one out. Okay, I'm not gonna lie, it took me a little while. I guess like, I don't know, it's almost lunchtime, half an hour, I guess. I found 2 ways to recombine attributes, I guess you can call it. In Houdini, technically, it's really, really easy. Like I can say I want my point wrangle, and I can say, well, the point wrangle, let's say my color, right, equals set, and I'll make it like all red, right? That's super, super straightforward. And now everything's going to be red. That's very easy. But of course, because how it works in Houdini. Now I found 2 different ways. The logical one seems to be using the math mix. And what you can do is to use the math mix. It was a bit tricky to find by name, I have to say. But if you connect now the tube or whatever you want, you can now combine attributes or make operations. One operations would be the A, which is the first one. And let's say that my scope is the position. So I'm going to make an operation with the position. And then I want my result scope to be called something else, like mask. And now you can see if I bring back the pop2, that I created a new attribute out of that. I guess for me it's a bit confusing because I'm creating an attribute in an operator called mathMix. And actually, it is a bit like, the naming seems a bit confusing to me, but it doesn't matter because now I can say my scope is p.y, which that would be like the height. And you will see that it becomes the same. So now if I just make it a little bit like that, it see that it cuts things in the middle. So it goes from 0 to 2. That is one way, which is literally setting the first attribute to the second that we are creating. Second way, which I think might be even better, is the normalize pop, and it's using the bounding box of the object. So what it's going to do is that it doesn't matter the height of our tube. It's going to normalize that value. So for example, that p into a mask, right? And I think I can say here p.y, and it's not going to work, okay? And maybe if I say p parameter 1, it does work, but how can I select box? There you go. So if I have I want the input of the position, the parameter output size will be 1, and I want the box y, right? So it's gonna take like that thing. And this is normalized. So I guess like that actually is a better approach. So I'm gonna keep with this. So these are like the discoveries. I'll leave the mathMix here. I'll comment it, sure. Oh, not the console. How did you comment? I forgot. Shift C? No. Alt N. There you go. Rename. No. Set attribute. Anyway, there you go. I'll leave it there. I'll keep this one. What I made now is then the mask attribute, which is really nice. If I plug it into the copy, now here I will get the mask most likely. At least I hope so. So I'm going to check if it's coming through the pop2. I look at it and I indeed get a mask attribute, and indeed it's getting to 1, which is, it's good. That's what I wanted. I'll leave that there. What I can do as well is with the mathMix, at least what I saw, is now I could visualize the mask, and I can say the operation is going to be A. My scope is going to be the mask, and it's going to return the color. And you can see that now I get the gradient. It's exactly what I wanted, right? Then what I have to do is to map the amplitude as I just did here with this one. So you can see that they have like the root stack. And that was because my map was set as mask with the parameter of the amplitude that I multiplied, right? That's what I'm going to do. I'm going to set it to multiply. My element will be my mask attribute we just made. And the parameter I want to multiply by the mask is going to be my amplitude. And now you can see that it works. There you go. And it's normalized, which I think is better than to translate one-to-one the position of the height. Because now I can make this noodle a bit longer and it still will work better, right? Perfect. Now I just made the first item, right? So I'm going to actually press X. So this is done. And now I still have this one to be made. Let me add it like this. So this, I have to get the ID from the sprinkle. This name, man. I cannot get over it. Anyway, I think I saw in the copy that when I copy the input tube with the points of the sprinkle, here I have like quite a few pages of data attributes, and I can see that there is a template attributes, and that would be my second input. So it's like the sprinkle, and the sprinkle I can toggle it on maybe, or I can use a template attributes, or maybe I could use, oh well, here the template. Then this is a point scale. There's a rotate vector. Here, perfect. There it is. Template ID attribute. And what I want to do is to set it into the point. And what this should give me, as you can see, is an ID given the number of tubes that I have, right? And this is exactly the same as my class here, you can see. And the class makes this attribute, which if I look at again, gives this randomized color, and there you go. I don't think I have here a function to randomize by number, but it doesn't matter. It will be the same. Then what I did, that's the last thing that I did here, is to generate this new noise to look up the coordinates on how to generate the Berlin or the simplex noise, and that's given by this lookup attribute. And by default, it's set as position, right? And you can see that now they all move in the same way. And maybe I'm going to make this period a bit smaller, so they're a little bit more funky, right? And I already said they break a little bit, so what maybe you can do is to add more columns or more rows, and you will see that it kind of becomes a bit smoother. Also be careful with the amount because it can be a bit much. I'll just leave it at 60-60, it's fine. Anyway, I think that I have to generate that P noise attribute, and that's going to be quite simple. I think I even had it here, right? No, that was to show the color. So what I'm going to do is a new math mix. I think that's the whole point of this. And all I did, if I check my Bex operation here, I'm adding the class to the position. And now our class attribute in TouchDesigner is called template ID. So that's what I'm going to do. I'm going to say A plus B. And then the A is going to be my position. And my scope B is going to be my template ID. And now you see, it's actually so cool. I love it. The designer is like so great to visualize stuff, right? And that is what's actually happening is that we see, in a way, we see how are we going to fetch the noise through these coordinates, right? Instead of all of them being in the same location, which they get this averaged position on the transformation, they will be sampled through this really funny kind of diagonal. You could even randomize that. So instead of using a template ID, we could use something more random, but I think that's fine. At least it worked for the other, right? So it doesn't matter. The thing is that it's changing the position. So the result scope will not be the position, but it should be the P noise, which is the same attribute that I created in Houdini. I'll just look at that. And now if we use that P noise to look up the noise attribute, I have to hook them up, of course. And then if I here, instead of the P, I add the P noise, you will see that now each of the noodles is individually affected, which is very, very nice. For the rest, I think that's mostly it. Actually, we got there also really fast, and the benefit of doing it here in the designer rather than to make things in Houdini is that it's a lot more modular, right? So we can change the height a lot easier. You can see here, we could also add it into the amplitude of my voice, and they could like grow. And there are so many things that we could actually do in order to expand that, right? Honestly, at the moment, I don't know to what extent you can do that. As I mentioned, first time I opened this, hey, it's me from the future, and I figured it out. So the thing is that I had to find a way to set this template scale, right? So if, for example, when you set it on, there is no attribute that sets the scale. What I was struggling is to how to create that P scale attribute, but it was kind of easy. I needed like a randomized pop and what it can do. And I'll get another of the pop tools. It's really nice. Big fan, big fan. As you can see, by default, it's going to randomize the position of the input. So if I change the seed, you see that now the positions kind of swap a bit around, right? Instead, what I want to do is to output a new attribute, and I'm going to call it P scale, just because that's how I used to do it in Houdini. And then you can see that it inherits the input attribute. In this case, because the position is a vector, then it also gives a vector. And the issue that I was having is that if I now connect it, you see that, I mean, it's kind of nice, but it's not what I wanted, because P scales in Houdini are a float, it's a uniform, and then it does not have like 3 components, so it scales uniformly. And now if I change the seed, you see that it's sort of a bit weird. Well, all I had to do, and you can do, is to select what component you want to scope for the randomization. And in this case, I want the Y, which is the height. And this one, it works because the way we made our tube, it's always positive, right? If you would select the X, for example, to sample random values for your tubes, then you will see that it sometimes goes to the negative. Now I go back to the era of not knowing, but because I used a lot of textures and I did a lot of things in the designer, I will assume that you can, for example, limit these things. So for example, you can probably limit an attribute, like for example, the P scale. And here we could also limit the value, right? So we don't allow it to go negative, or we can loop it like that, as you can see. And now the values are not that well. But for now, I think keep it easy. Leave this to sample the position Y, and it's a lot nicer. And actually, we got really, really close to how it was here, right? Maybe the last thing that we could actually add is a noise before the movement, which can randomize the position of our tubes, right? And that will, in a way, also kind of resemble a bit more these shapes. And the way I did it, I also used the mask. So probably I'm going to map it again, where I'm going to get the mask and I'm going to map the amplitude. And it goes completely crazy because instead of setting it, I want to multiply. And that you will see it then in the bottom, the amplitude is not that affected. And at the top, it gets more noise. And now probably I just want to make this noise a little bit more big, and maybe the amplitude a bit bigger, so it's a bit more wacky, right? Like that. There you go. It's very strange, but it kind of works. Mostly it is not the same behavior because we get these strange caps that I don't want to spend time right now to figure out how to change. But there you go. This is the recreation of that Houdini network. And you see that it actually doesn't take that much, to be honest. And now and for the future, what it takes mostly is just knowledge to figure out how it's going to work. But once you know, I think that you can do both ways quite easily. That's what I meant by interchanging knowledge between the softwares, which I would highly, highly recommend. This will be it for me. Let me make this big again with the beautiful output. I will leave a link so you can download these files as well. You can just play with them. I will put it for free. I think it's just fun to play around, but consider to just send something if you are going to use it or whatever, up to you. Some people can, some people can't. Just do what you can. And that's it for me. I'll keep an eye on this. So let's see. You probably will see quite strange things coming from me with using these setups. I'm very excited. Probably a lot of weird things with faces. I think you will see a few pictures here, but yeah. Keep in touch. Have a nice day. Have a nice minute and see you. Bye-bye.